Hello everyone. Today we are going to discuss about the power flow diagram of DC machines. So first, to know about the power flow diagram, we have to know how the power flow works in case of DC machine, which includes generators as well as motors, right? So in case of generators, as we know that the mechanical power is getting converted into electrical power, right? Now, during this conversion of mechanical power into electrical power, uh, it is the power which is given as a mechanical energy undergoes some losses and then it is getting converted to electrical power. So, generally, uh, before getting converted to electrical power, the mechanical power input or mechanical power given to the generators incur some losses like we can say generally as mechanical losses. So these are mechanical losses. So after conversion, when we get the electrical power also incurs some losses which are known as electrical losses, right? So in the diagram over here, in the left hand side, we are going to see the power flow of a DC generator. How does the mechanical power is getting converted to electrical power? So first of all, we are giving a mechanical power input to the machine, right? So here we give mechanical power input to the machine, right? So as we all know, the mechanical power input or Pin will be given as omega input or the angular speed or angular velocity, angular speed in radian per second and the torque or applied torque, right? Now, after getting converted to electrical power or before getting converted to electrical power, it incurs some losses. So, this slide shows the losses that is going to be incurred before conversion of mechanical power to electrical power. So, this conversion, as we all know, as we have seen that these are called mechanical losses, right? So, mechanical losses includes friction losses, windage losses, stray losses, and as well as core loss. So these are the losses that is being included before the conversion of mechanical power into electrical power. Now, after this losses has been incurred, we get over here the mechanical power converted as or converted to electrical power, right? So here the equation will be P converted equals to omega m or omega mechanical multiplied by the induced torque, or this can be written as Eg into I, right? Or generated EMF into armature current. Now after this, after the electrical energy had been produced, it will undergo some losses, right? So these are electrical losses. These are all electrical losses. Now electrical losses, uh, after the inclusion of electrical losses, we actually get the electrical power output, right? So these are electrical power output. Now electrical power output can be written as P out equals Pg, or generated power, equals to Vt into, or the output voltage that multiplied by the load current, right? Now the omega m or omega n is equals to the angular speed of the armature, angular speed of armature in rad per second, right? And the applied is the applied torque in Newton meter, right? So now the conversion, or the conversion power, or P converted, can be written as the input power Pi minus stray losses minus mechanical losses and core losses, as we have written it over here, right? So the converted power can also be written as the generated EMF that multiplied by the armature current. Now the output power, in case of output power, the losses will occur on the converted power, right? So P converted minus electrical losses, or renownedly known as I square R losses, minus the brush loss, right? Which in turn gives Vt into IL, which is the terminal voltage and the load current, right? Now we come to the motors. Now the motors part, we know that motors convert electrical to mechanical power. Now the electrical power first incurs some electrical losses before conversion, and mechanical power, before the production of mechanical power, it incurs some mechanical losses, just like the previous one in reverse order, right? So here we can write that P input is equals to, sorry, P input is equals to Vt into IL, which is actually the output for in the previous section or the previous part or for generators. Now P converted will be the input power minus copper losses or electrical losses, right? Before conversion. So this is the converted part, and the converted part can be written as we can see over here, P converted equals to omega m that multiplied by the torque, right? Now the output power will be omega m into load torque, right? So the output torque that is being generated is actually the converted power minus the core loss, mechanical and stray losses. These losses, mechanical loss, core loss, and stray losses. Now, many people have confusion about these stray losses. Uh, Stray losses are nothing but the losses which occur not due to the core of the machine or not due to any kind of uh, electrical losses or I square losses. Uh, these losses are actually the losses due to the temperature increase of the machine while it is running. So this temperature increase or heat increase is actually some energy loss, and as well as the sound the machine produces, this sound energy or the conversion of sound energy in any kind of machine, whether it be generators or motors, the sound which has been produced, this also can be included as sound energy. So these energies which are not useful to us is included as stray losses, right? So that's it for the power flow diagram of DC machines. Hope you all are doing well, and we'll continue in our next class.